And again, welcome to each one of you. ADHD was the thematic that the Klika chose for these 2 days, from several suggestions from my part, and also in combination with math for this one day. So, of course, to have an ADHD diagnosis does not mean that you have learning problems specifically in maths. But there are some connections, and what there is quite some research on is that when you have an ADHD diagnosis, you struggle with the processes in front of your brain. We are not going to talk much about that today. That's what we did yesterday. But those who have problems with the executive functions, the planning processes, will often have challenges when there is novel tasks. And especially in the problem-solving part of the mathematics, the tasks typically are new all the time. And it demands thinking and planning on the children, adolescents, when they are in the 5th and 6th grade. They are still children, aren't they? It's okay to speak about children. But before I start, let me present myself a little bit. I am a teacher as well, with experience from primary school for quite some years, and primary and lower secondary mostly. My master is in education, but I've worked a lot with special needs education. In Norway, we have a system with that the children who struggle at school are referred to the school psychology services. I'm not a psychologist, but in the school psychology services also special needs teachers and other professionals work. So I appreciate very much my experience from those years I worked there. I met a lot of children with needs in different ways, and because of my experience, I was the one who got all the math cases in our office. So whenever there was a math problem mentioned in the reference, then it was my case. And it was, I liked that very much. It was very interesting. So you can also see the name of my colleague and actually also my husband, Morten Ahem, here. We work together in Pedverket Kompetanse, which is a very small competence center. And we work with special needs teaching. We give courses in the concept teaching model that I'm not going to say a lot about now, but about concept teaching, basic concept teaching, and also basic teaching, because that's most relevant and most important in the transition that children typically are in at the age of 4, 5, 6 years. We also have the Norwegian version of the cognitive assessment system, CAS, and we work a lot in training school psychologists for that. So that was a little bit about us. Morten, maybe you will say something and show your face.
I can say hello, of course. Maybe all the audience know both of us from before. If not, we can tell that we are working together and we are married and we are working with this area, both of us, and have a lot of nice discussions. And Gunvor will present because my English, I think it's not so good, but that doesn't matter. So I speak even if I'm not so good in English. That's okay. And I wish everybody welcome. See that the last two was just coming now, so just go on, Gunvor. That's fine.
Sorry, we can't hear you.
Of course you can't hear me because I'm muted, not to interfere with the sound, Morten. Excuse me for that.
Then you might repeat your question to Michaela and
Actually, I didn't have a question. I said welcome, and we want to hear a little bit from you too in a while. And please, will include you also in the messages that please take the word, ask questions. You can also write them in the chat. So this picture is taken from our homes a week or two ago. And so we have a lot of snow this winter in Norway. I don't know how it is in Czech. Norway and Czech at least has that in common, that we do a lot of winter sport, isn't it true? Compete in the cross-country skiing and in this, I don't know the English term, but when you go cross-country and you shoot the targets in combination. That's something we have in common, the two countries of ours. So when we are speaking about math, we are speaking about something we need to understand the world around us. But what we are, when we speak about math knowledge and to learn mathematics, we speak about also things that's going on in our brain. And in our brain is built up from 100 billions, more than 100 billions of neural cells. Small, so we can't see them, but they are there and they are doing the job for us. And it is interesting to read professionals, authors, researchers who have worked on how is the connection between these physical things that goes on in our brain and our thinking, our mind, and all that's included in that. I show you this picture. It demonstrates what has been called the PASS theory, the planning, attention, simultaneous, successive theory of cognitive processes. And when this theory was published in 1994, the intention was to replace the old definition of intelligence that was made up on the basis of psychometric research. With new neuropsychological research, there was those people, thus Naglieri and Kirby, who authored the theory. They thought it was a good idea to take all this research into account. And they used the Russian neuropsychologist Alexander Luria's works. And Luria, he described the brain in terms of these four categories, types of processes. And let me try to simplify a little bit. When you see, and when I see this picture now, we pay attention to that. And attention is somewhere back here in our brain. And it's this part of the brain is called the reticular activation system, and its task is to activate the rest of the brain and to help us focusing. So when I ask you now to focus this teacher and notice these different parts, and you can see that the blue in front, planning, and whatever goes on in this part of our brain is also often called executive function. So what you've heard, learned about executive function, you can also apply and think of when we speak about planning. And then we have this part of our brain, all this tissue, brain tissue that's folded and folded and contains a very large number of brain cells. And they operate and they work, function in two different ways because they relate to what we can see in one moment simultaneously. We get a big picture like we do when we look at a map or a picture taken from an airplane. We get the overview and we can see how things belong together in different ways. Not only what we see can belong together in such a way, but also our knowledge is connected. Different elements to each other, and very often when it comes to the knowledge, it's because there are some certain similarities that connect them and gives us a big picture and helps us understanding. On the other hand, we have the successive processes, and the successive processes they take place in the course of time because it is about one thing after the other that comes to our senses, like when we read, for example, we relate to letters and words in a sequence. And when we speak, we utter speech sounds in certain sequences, we utter words in certain sequences, and our brain works in a successive way. So both simultaneous and successive relates to what we take in through our senses, and also to what we perform, what we can do. We are going to return to these different ways of knowing and ways of having knowledge later. What we take in, what we elaborate in this part of the brain will also reach to the front of our brain, and that will guide and direct what we perform, what we do. And we can speak about planning as the captain, the director of the enterprise, and in such words that also gives us some ideas about how this part of our brain works. So let this be a common basis for what we are going to speak about when we also speak about the knowledge and how to learn maths. And I've marked this part of the brain because that's also the part of the brain that often has challenges when a person has an ADHD diagnosis. This diagnosis is set according to behavior and according to experienced emotions and experiences of a person in different situations. So it's not, the diagnosis is not set according to brain functions, but what have been seen in research is that when a bigger group is assessed regarding these 4 types of processes, there is a dip down on the planning on a group level. So that means that this executive function, to get things done in a good way, to monitor your work, etc., etc., that's more problematic for the children with ADHD. And that relates also, and is also the case when it comes to the math activities and learning. In our long-term memory, we store the knowledge that we have. And through the decades and centuries, people have discussed this, where are all our knowledge? Is it something we carry in our brain, or what? And there are good reasons to say yes to that. And a lot of research has found evidence and accounted for such a way of understanding it. Our long-term memory, the different types of knowledge that it has, and here you can see an analysis of it. And if we look at one of these categories of knowledge at the time, we will get understanding of that. And I can tell you that those professionals who have developed this analysis of the long-term memory, several researchers has done. One of them is Magne Nyborg, a Norwegian researcher in pedagogy. He was very occupied with what can we do for children, those children who struggle with learning. In particular, what can we do for them to make learning easier? And what can we do for all children in this age from 5-6 years to prevent learning problems at a higher stage and more elaborate learning that will come later. Nyborg is very clear in his writings about the reason why he analyzed them just like this. And he says it is because knowledge we learn through a set of processes, and skills we learn to another set of processes. And the learning processes are different, and he found that to be a good reason to speak about them in this way. And we shall see in a minute that actually maybe it is a good idea. Well, that will be up to your evaluation when we have worked with this for a while, but a good idea to do this analysis and to look at these categories regarding math learning and math knowledge. Knowledge on one hand, what we know, all the facts that we have learned, all the concepts that we know, and if we try to think of our knowledge, we know a lot of things, and we know some specifics, and we know a lot of overviews and comprehensive knowledge. On the other hand, we have a lot of skills. You have demonstrated that you have the skills of speaking, to utter words, and to relate and use the speech sound needed to utter the words. We all have the skill of reading and writing, and we have a lot of other skills like singing, like skiing, like driving a car, like running a bike, and so on and so on and so on. And all those skills, what they have in common is that when we learn them, we learn this consecutive series of movements, for example, in motor skills, in the sequence that they occur and that they must be performed to be able to perform the skill and to do these activities that the skill helps to. So the successive and or the sequential is very important when it comes to the skills learning, while the overview, to see things in relation to each other, that's important when it comes to the understanding also of the mathematics. And you can see here is also a word like dispositions. And that means what we are ready to feel or to be motivated for based on our previous learning. And those kids that has failed again and again and again in the math lessons, they will probably connect the bad emotions, negative emotions, to the math, to the whole subject, to those lessons, and maybe even to the math teacher. When we are in the 5th and 6th grade, some of the pupils may already be there. They have failed through those first school years, so that they don't expect to learn, they don't expect to succeed, and that of course, activates negative emotions in them. So what we can do is to also, with these groups, to work deliberately and see how can we work with providing for them learning of the needed concepts, and how can we facilitate the skill learning in ways that also will help them to succeed. So let's have a look at one way of analyzing mathematics skills and sub-skills, and especially for children and be advised, will ease the burden in a math lesson when the child is asked to use the math knowledge and to solve new problems. Now I got a message from my computer that my connection is unstable. Is it influencing the sound and the hearing? Please give me a word if that's the case, because then I need to switch the connection.
Only sometimes some words are not very clear, but it's much better than yesterday.
Okay, I'm glad. I have another connection today than yesterday. So I'm sorry for this. The sound is always a challenge. I will try to speak not too fast. That could also make it easier. I'll try to restrict myself. So calculation skills, of course, are important when it comes to the math skills. And what I should also have added on this list first is counting skills, because counting skills is also very important. And I'm trying to tell my son and my daughter-in-law, they are exercising some counting with their son of 2, soon to be 2.5. What I have noticed is that they just use the number words in a sequence. And they think they teach him how to count. And they teach him a row of words, actually, but counting is not a part of it until also the child learned to combine the number words with items to count. So that's an important part of the learning how to count. And when the children both have the knowledge of relating the exact numbers to the number word, and also to utter the number words in the sequence, that's when they have learned to count. And of course, it's a basic kind of knowledge when it comes to math. And the skills of saying the words in a sequence, that's a part of it. Calculation skills is also a diverse category, because to that category belongs all these number facts that we have exercised again and again, like the addition table, like everything that becomes 10 together, or becomes 8 or 5, or even 14 or 17 or 20. When we have automatized such number combinations, we have a skill, a calculation skill that we can use to find the answer. But again, the skill must be related to knowledge about the actual numbers related to these words before it becomes a really type of knowledge that can help you solve problems. So calculation skills can be connected to the addition tables, both from 1 to 10 and 11 to 20. And in Norway, we had a professor of math in the Institute of Education of Special Needs Children in the university in Oslo. And he was very deliberate on this. It's important to teach the children to automatize all these number combinations, because that makes all the math work easier for them. And the same with the subtraction tables, actually. I don't know how it is in Czech, but in Norway, it hasn't been that common through the years to automatize all these addition tables. The 10 friends has for many, many years been a concept and means all the combinations that comes to 10. But the same is the fact for all the numbers up to 20. Multiplication tables, it's much more common in Norway to exercise them. Is that the same in Czech?
No, we usually try to memorize the lines, but we don't use the table for that.
Okay. And then you're speaking also about addition and subtraction? Yeah.
Yes, that's the same.
Yeah. So there are also skills connected to the algorithm, the ways of doing it. When it comes to more composed tasks, more complicated tasks. And we are going to speak about some of those today. So addition with multi-digit numbers, and also the same with subtraction and multiplication and division. Some of these, maybe actually all of them, are mentioned in this curriculum for the 5th and the 6th grade in the Czech schools. So let's, just a note to self and to all of us that the skill learning, as I've already said, is always also related to knowledge. And knowledge based on conceptual, now I have to, no, let me see. Role of processes and role of knowledge is something this picture tells us. But I think I will go to the next picture because I want also to focus the number concepts. When we have an amount of things, a reasonable number of things, we find the number by counting. And as I said, just to say the number words in a sequence must be related to also knowledge about the actual numbers. But we find the number always by counting until it's might be automatized. Like the dots on the dices, for example, we push the dices and it rolls and it stops and it gives us a number of dots. And many children memorize, not deliberately, but that happens if they play a lot of games with dices, and they will get an automatization of the number when it looks exactly like that. But they will need more knowledge to really have a flexible concept, for example, of the number 5. And I suppose that you can imagine what the 5 looks like on a dice. When we have a number concept, we can immediately identify numbers, groups with certain numbers on the basis of that, because the groups are typically can be different in a lot of things, and also in the placement of the items according to each other. But what is constant is only the number. Can be similar in other things, but doesn't have to. We also have concepts about number units. And as you can see from the examples here, then we speak about the decadic units, and also the decimal units. And we could also add a subcategory of all other measuring units that we use for measuring length, for measuring areas, for measuring weights and volumes and so on. We'll return to that later. So the units are very important, and not least when we speak about fractions and the decimal numbers and percent, which is something that very often is introduced at this age that we are focusing most today. Maybe I should say that I recommend to teach this and to relate to these issues maybe a little bit more in the concrete world than the mathematicians sometimes do, and also than some math school books typically do. So maybe it's not so common to speak about concepts, about changing numbers. And then, of course, we speak about all the types of calculations, adding, subtracting, multiplication, division, and different variations of those. That's also something that we need to learn concepts about, because we need to know when we have a problem, what kind of calculation method should we use to find the answer in this situation? What is it that can help us in the situation? So these concepts are very important as well, and maybe not so usual to focus on and to teach. We also have relations between numbers, and they are typically taught, like a large number related to, or bigger and smaller numbers, maybe is more frequent used ways of uttering it, and also similarity in number with the equals sign. We also have a category of math symbols, like the number words are, like digits and other symbols used in mathematics also are. And they are symbols for exactly numbers. They are symbols for the changes we can do in number, and in that way the calculation, and so on and so forth. And we are going to work a little bit on this concept of symbols, because maybe that's not so common to teach. How is that in Czech Republic, actually? Does the math school book have something, or the school books in general have something about symbols, to learn the general concept of symbols? No, not in Norway either, actually.
No, I'm sorry, I am not that educated or experienced as an English teacher. Yeah, so probably my colleagues could say something.
So please let us know if this is something that that's included in the school books, in the curriculum, because I've only seen the 5th and 6th grade curriculum that they sent to me in English. I don't hear anything, so maybe it's not so common in Czech either.
Okay, I will ask in Czech. Můžete prosím někdo říct, jak je to v českých učebnicích, jestli se tam pracuje se symbolikou nebo jenom s čísly?
Maybe not. My interpretation is not. So and actually it hasn't been in Norway either. As a teacher, a much younger teacher, when I had been teacher for like 5-6 years, I think, and then I was a student of Nyborg, as I told you about, with the concepts and the concept teaching, and he just mentioned this about symbols. And at that time, I had a girl in my class this was the 2nd grade, so it was more basic maths teaching and learning than what we are going to focus today. And in this class, there was a girl, and she was very kind of hesitating in her math work. She was not sure of what to do and what to write in her book. So she needed an adult next to her. And if she didn't have that, so that she could find out things, but she was not sure it was correct, so she wouldn't write it down until she had checked. Somebody had told her, yeah, this is correct. And I was the class teacher at this time, many years ago, and I was the student of Nyborg, and I heard about the symbols, and I thought, okay, this girls, maybe this about symbols is something that will be important for her to learn. And I checked out a little bit with the class as well, and I haven't put this in a picture for you, but maybe you can imagine. I wrote the digit 8, the equal sign, and another digit of 8. And I asked the kids, is this correct? Can we write it like this? They just looked at me as I was a little bit weird. And they said, no, you can't write it like that, because we must first write a number, and then plus or minus, and then another number, and then comes equals. So okay. So I understood, okay, this is about symbols and different symbols in math. Actually, they can relate to it, they can use it, and to a certain degree at least, but they don't actually have this metacognition that they can explain and actually know what it tells us in general. In the specific situations, in these algorithms, they could recognize it and use it, but not as something with knowledge regardless of the situation, not connected to a situation. So we worked on symbols, and I tried to find out what is it that works as a symbol for these kids. And we are going to return to that. I'm going to show you a little bit of what we did in that class. And later I become the author of a school book in math for the beginners. And I added this symbol thing because all those I tried it out together with when I also trained other teachers. They, some of them hesitated in the beginning, but then they realized, okay, this is something we actually have to do because it is so helpful for the children. But before that, let us have a look at the Korean number words. I don't know how it is in your language, but at least in English, note what happens when we have in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, like 11, 12, 13, three totally new words for these three numbers. But look how it is here in Korean. 11 is sip il. And what is sip? Look over here with 10. Sip is 10. Il is 1. So sip il means 10, 1. 10, 2. 10, 3. 10, 4. 10, 5. 10, 6, and so on. And this system is kept from the beginning to the end of the numbers between 1 and 100. And probably it continues after 100 as well. I don't have that. I found this in a book years and years ago. The title of the article in this book that was authored by Robert Sternberg, an American professor. The title of the chapter that he hadn't authored was On the Shoulders of Giants. And those giants was all those who has generated new knowledge, who has generated the language to speak about math with. So the numbers word system is a part of such heritage from people that has been living before us and used these words. So in English, in Norwegian, it is just like in English. So I'm a little bit curious about how it is in Czech, whether you have a system more like the Korean number words or it is more like the English.
I would say it is more like English because we have some similar sounds. For example, jeden for one, jedenáct for 11,
Yeah.
dvě for two, and dvanáct for 12.
Yeah. And what is 10 in Czech?
10.
10, okay. So the 10 word is not present in these words, but they have something more or less similar with the 1, 2, 3, 4. Yeah.
Yeah, it occurs in numbers over 20. 20 means is 20 in Czech, and then we say 21.
Yeah. And then you keep the system. Yeah. And that's also the same, actually, 21, 22, 23 in English, and also in the Norwegian language. So all these European languages, I think, is more or less similar in this, that it is the words between 10 and 20 that has an other, they don't really follow the system like the Korean's words does. And what this author, I'm sorry, I can't remember his name, but if anybody's interested, I can find it. He referred to some research saying that in the years, the school years, where the majority of calculation is within this area of numbers between 10 and 20, the Asian kids, because also other Asian languages have the same system as the Korean, and they perform better than the Western part of the world. And that's quite interesting, actually. And it does make sense, to me at least, because it's easier to understand the actual number, not only some numbers that go together in specific ways, but to relate it to reality and to the real numbers, and to get a system in it. Now I've been speaking a long time without maybe actually coming to the objective. So let me do like this now, and I'm going to return to the Czech curriculum. But let's have a break first.